Hello everyone, this is Dilip Chakravarti belonging to Cyber Security Department in IARE Engineering College. Today we are going to discuss about queues. What are queues? We all know that queue is a linear data structure. Actually, what is a data structure? A data structure is a way of organizing the data and the set of operations that are performed on the data. Okay, we classified this data structure into two types: uh, primary data structures and secondary data structures. In secondary data structures, so it is again divided into two types: linear data structures and non-linear data structures. So linear data structures means how we are placing the data. We are placing the data in sequential manner. That is one after the other. Whereas in non-linear data structures, we are placing the data in hierarchical order, not sequential order. We are not placing the data one after the other. Okay. Now let's see about queues, which is a linear data structure. Okay. So a queue can be defined as an ordered list which enables insert operations to be performed at one end called rear and delete operations to be performed at another end called front. Okay, clearly we can say that a queue is a linear data structure where insertions and deletion takes place at two different ends. Okay, we are inserting at one end and we are deleting at another end. Okay, where insertions and deletions takes place at two different ends. Whereas if you observe there in stack, so where insertions and deletions takes place at one end, we said, okay, that is top end. But here in queues, we are inserting at one end and we are deleting at another end. Okay, so insertions takes place at rear and deletions takes place at front. Okay, so we are following a principle called first in first out. Queue follows a principle called first in first out. Whichever comes first, that will be deleted first. Okay, that will be removed first. Okay, for example, generally if you observe a general example, if anybody are standing in a queue, so observe this diagram. So people came one after the other. This person came after that. This person, like this. If any new person comes, they will be added at the end of the queue. Okay. After completion of the work, so this person will move. Okay. So that is what he's saying. So it is a queue where insertions take place at one end. We are inserting at last end. We call it as rear end. Okay. Where deletions takes place at front end. Okay, I hope it is clear. So the simple definition is queue is a linear data structure where insertions and deletions takes place at two different ends. Okay, so then what are the operations we are going to perform on queues? So we can insert as well as we can delete. Okay, so here in queues we call insertion as enqueue. We'll name it as enqueue. The technical term used for insertion in queues is enqueue. Similarly, the technical term for deletion is dequeue. Okay, so enqueue means the enqueue operation is used to insert the element at the rear end of the queue. Okay, DQ means DQ operation performs the deletion from the front end of the queue. Okay, we'll be deleting. Observe this. So people will elements will be inserted like this. Okay, so one after two, two after three, three after four, four after five. At rear end, we are inserting, we are enqueuing. Okay, at front end, we are dequeuing, we are removing. Okay, so these are the operations. Similarly, we can display the elements in the queue. Suppose if you want to know how many, what are the elements that are present in the queue, you will be displaying it from the front to rear. Okay, so starting from my front to rear, I will be displaying first element, second element, third element, fourth element, fifth element, like this. Okay, so these are the operations of queues. So here I named it clearly about the operations. So a queue is an object that follows the following operations. It is following some following operations, maybe enqueue, NQ is nothing but adding an element to the end of the queue. DQ, remove an element from the front of the queue. Okay, is empty. I'm checking whether queue is empty or not. Okay, only if queue is empty, only we can insert the elements. If not, we'll get a overflow. Suppose if queue is full, we'll get something called overflow, as we have seen in stack. Similarly, here also. So if queue is full and still if you are trying to insert, you will get a overflow condition. Okay. So similarly, we can find the size of the queue. It returns the number of elements that are present in the queue. Okay. So first it gives the front value, front of the queue. Okay. Whatever we are going to remove, so it gives you the first value. Okay. So these are the operations we are performed on. Okay, fine. Now, how we are going to represent queues? So there are two ways of representing queues. So one is I can use array for representing my queue, and the other one is linked list for representing my queue. Okay. So if you are using an array, okay, what do you mean by array? So array is nothing but we are collecting the elements. We are collecting homogeneous elements, and we are storing one after the other. Okay. So here it uses a one-dimensional array. The queue uses a one-dimensional array, and it is a better choice where queue of fixed size is required. We are taking the size of the queue here. Okay. Up to that only we can insert the elements into the array. Similarly, linked list. We will take a linked list for representing my queues. So what is linked list? Linked list is nothing but which consists of nodes. Okay. So which consists of nodes. So here in nodes will be nodes consists of two parts: information part and address part. In information part, we will be storing the information, whereas in address part, we will be storing the address of next. Okay. So by using this linked list also, we can represent the queues. Okay, we will see these two things clearly. Okay, if you use a linked list, so no need to mention the size. Why? Because so we can extend the list. Okay, no need of giving the size. Okay, we will see all these things clearly. So now let's see about the representation of queues using arrays. A one-dimensional array, say we're taking the queue, which can take up to n values, starting from 1 to n. Okay, we are representing like that. If suppose if you are storing n elements, you will be representing an array as q of 1 to n. Okay, so it can be used to represent a queue. So here we'll be using two pointers. One is front pointer, and the other one is rear point, which indicates the two ends of the queue. Okay, this one is starting one is front end, and last one is we call it a rear. Okay, inserting element. So we are inserting the element at rear end. Always a new element will be inserted at rear end, and the element will be deleted from front end only. Okay, we are going to delete the element from front end only. Okay, insertion of new element, the pointer rear will be consultant, and for deletion the pointer front will be consultant. Okay, so this is a simple representation of an array queue using arrays. Okay, so here I have given some steps for inserting or enqueuing an element into queue. Okay, so before inserting, first I should know whether there is space or not. Okay, so if queue is already full, so I can't insert the element. Okay, so I'll get something called queue is full or overflow. Okay, so I'm just checking. How can I check means? So I'll be checking my condition if rear equal to size. When rear will be moving to the size, then rear equal to size will be getting. If already rear has reached to the maximum size. If queue is full, at the time rear is at last element. Okay, so if rear equal to size, then it means queue is full. Otherwise, so what we need to do? So we need to add. Okay, so before adding, so we are checking so whether it is the first element. If queue is empty also, if queue is empty, so my rear and front points both to 0. Okay, so then what I need to do? I have to move my friend. Okay, so I'll be just moving my friend element. Okay, so otherwise, so I'll be moving my rear end also. So if that is the if queue is empty, I'll be just incrementing my front and rear. Okay, I'll be incrementing both front and rear. But if already elements are there in the queue, I'll be just incrementing my rear end node. Okay, so we'll be incrementing rear end, and I am placing element at that rear position. Okay, I am placing that item at that rear position. So Q of rear equal to item. Okay, so this is for algorithm for NQ. Now see algorithm for DQ. So for deleting an element from a queue. Okay, so if you are trying to delete an element from queue, here also first we need to check whether elements are there. If elements are there only, we can delete. Okay, how can we know whether elements are there? Okay, so here we are checking a condition that front equal to 0. If front is the position of front is 0, then queue is empty. Nothing is there in the queue. Okay, if otherwise, if front is not equal to 0, so then what I need to do? I need to remove the element from front side. So I need to remove the element from queue, which is at front. Okay, so queue of front will I'm considering it as item, and I'm just removing it. If front equal to rear, so front will points to 0 and rear points to 0. Okay, if only one element is there, and what I'm doing, so if both are same, front and rear are same, so I need to make front and rear as 0. Otherwise, just front will be moved to the next position. First element will be deleted and front moves to the next position. Okay, so this is the algorithm for DQ. Okay, we will see diagrammatically. Okay, we will see the example of queue using arrays diagrammatically. Let us consider a queue, so which can hold a maximum of 5 elements. So here I can store 5 elements. Initially, so my front and rear, so both are both points to 0. Okay, so if you are taking it as uh, array, if you are considering as array, both front and rear will be -1. Okay, after inserting an element, so both front and rear comes to 0th position. Okay, so both front and rear comes to 0th position. So now it comes to 11. 11 will be here. So again, if you are inserting one more element, rear will be incrementing rear only. Okay, so then rear is incremented, then again rear is incremented, then again I'm trying to insert 33, so then I am inserting. Okay, after inserting uh, so 11, 22 and 33. Now suppose if I am trying to delete an element, so after inserting 33, what I am doing is I am trying to delete an element. Okay, so deletion means, so where it will be removed, so it will be removed here. Okay, so 11 will be removed. Okay, so then front comes to the second position. Okay, then 22 will be removed, so then front comes to the next position. In this way, I got all the elements. Then I inserted 44 and I inserted 55. Now if I am trying to insert one more element, even though there is space in my queue, so we are unable to insert. Why? Because already queue has reached to its maximum size. Rear has reached to its maximum size. As rear reached to the maximum size, so I can't insert the element. Okay, so here is one thing we can have a method to insert. So what we'll do is we'll shift all the elements. So we'll shift all the elements. So here, so 33 is shifted here and 44 is shifted here, 55 is shifted here. It's a difficult process. Okay, so for shifting all the elements, it is difficult process. To overcome this, so we went to some concept called circular queues. Okay, so by using circular queues, we can insert the element. Okay. Next, representation of queues using linked list. Okay, I hope you are clear about the representation of queue using arrays. Now, similarly, we are representing a queue using linked list. Okay, how we are going to represent? As I already told you, linked list consists of nodes. Okay, so here, if you observe, these are all nodes. This one, this one, this one. All these are nodes. Okay, I'm just incrementing my. I'm just adding my node at the end. Okay, at the last. That's why we call it as rear. At rear end, I am inserting. At front end, I am deleting. Suppose if I delete, I'll be deleted. Okay, so here what I said is queue can be represented using linked list. And in a queue, data is deleted from front end and inserted at the rear end. Whatever I said. Okay, we can perform similar operations on two ends of a list. You can use two pointers, front and rear, for our linked queue implementation. For noting the for representing the node, so we are using two pointers, front and rear. Okay, at front end we are inserting, and at rear end, sorry, at front end we are deleting, and at rear end we are inserting. Okay. So that is about how we are going to represent queues. Okay, next, application of queues, where we are implementing these queues. Okay, queues are implemented in various places. So it is used to schedule the jobs to be processed by the CPU. Okay, now for example, suppose if you give three works for a CPU, if you click, if you try to, if you are clicking some movie, if you click some movie, if you click some, if you are trying to open some Word document, and if you are trying to do another work in our system, if you are giving all these works at the same time to the CPU will schedule, okay, which jobs comes first. Okay, whatever the thing you performed first, so that will be done first. Okay, so then the next thing will be done. Then the next thing will be done. Okay, lastly, we are removing also. Okay, first one will be completed first, second one will be completed next, like. Okay, so then second application, when multiple users send print jobs to a printer. If you are giving if lot of users are giving print to a printer, for one printer, okay, each printing job is kept in printing queue. We are placing it in a printing queue. Each printing job is kept in a printing queue. Then the printer prints the job according to the first in first out, whichever comes first. Okay, whatever the job comes first, it does that work, and it removes that. Okay, so the printer first, it prints the first job whatever it has received. Okay, so here it applies the principle of this queue. Similarly, I can use this queues in searching also. We are having something called breadth first search. Okay, so in a graph, we will be using this breadth first search to find an element. Okay, so for breadth first search, I'll be using this data structure called queues. Okay, so these are some examples of applications of queues. So where we are applying the queues. So finally, we conclude with the types of queues. Okay, there are different types of queues. So we'll see one by one. So first one is linear queue. Okay, a queue is a linear structure which follows a particular order in which the operations are performed. Whatever we have seen up to now, so that is a linear queue. Okay, the order in first out. So whichever comes first, that will be deleted first. Okay, insertions occur at the rear end of the queue, and deletions are performed at the front end of the queue. Okay, so whatever the normal queue we have seen up to now, we will call it as linear queue. So then circular queue. So here, as I said, even though there is space in the queue, sometimes it is difficult to insert the element. Okay, if front points to the next, if you delete an element, front will be moved. Okay, so but rear cannot be. Rear is not moved. Only rear we will be keep on inserting until rare reach to the maximum size. Rare reach to the maximum size, even though there is space at front, we are unable to insert. Okay, to overcome that drawback, we went to circular queues. Okay, here it has given in a circular queue. So the last element points to the first element, making a circular link. Okay, so what we are doing is, so the last element here, if you observe, this is a linear queue. So 10, 20, 30, 5, 15, 25. So this is the last element. So if it points to the first element, okay, if it is pointing to the first element, then we will say it as circular queue. Okay, the main advantage of circular over simple queue is better memory utilization. As I already told you, so memory is not wasted in circular queue. So in normal queue, even though there is space, we are unable to insert. Okay, but in circular queue, we can insert the element. Okay, so this is a linked representation for circular queue, and this is the array representation for circular. So if the last position is full and first position is empty, observe here, if the last position is full and the first position is empty, we can insert an element in the first position. We can insert the element in the first position. So this is not possible in simple queues. Okay, so this is about circular queues. Then priority queues. A priority queue is a special type of queue in which each element is associated with a priority. So for every element, I am assigning a priority, okay, and it is served according to its priority. So here also we'll be using elements. We are inserting the elements at rear end, and we are deleting the element. But here each and every element is given a priority. Okay, based on that priority only, so it does the task. If elements with the same priority occur, they are served according to the order in the queue. Okay, so they are served according to the order. Whichever is the first, will be using that one. Okay, insertions occur based on the arrival of the values, and removals occur based on the priority. So here we are inserting based on the arrival. Okay, arrival of the value, and removal occur based on the priority. So if whichever is having highest priority, we'll be removing that first. Okay, so and next double-ended queue. Okay, so here we can either insert or delete at both the ends. Okay, so in normal queue, we will be inserting and deleting at different ends, but here we can insert and delete at two ends. Double-ended queue is also a queue data structure in which the insertion and deletion operations are performed at both the ends, front and rear. Okay, so that means we can insert at both front and rear position, and can delete from both front and rear position. Okay, is that clear? These are the different types of queues. Okay, I hope it is clear. Thank you.